In this video, we will be solving Airbus's supply chain issues that arise as a result of Brexit. The aerospace industry accounts for 0.7% of the UK's output, 7% of the UK's manufacturing output, and employs over 114,000 people. The UK has long been a predominant figure in aerospace, evidenced by the fact that 17% of the global aerospace market is supplied by UK manufacturing. Aerospace firms often distribute their operations internationally to exploit differences in specialisation between countries. And with the EU being destined for roughly half of the UK's air and spacecraft exports, Brexit therefore poses an obvious risk to the fluidity of the manufacturing process, inspiring this application to game theory. We now focus on a major player within the aerospace game, Airbus. Like most aerospace companies, Airbus's production is international, operating mainly within the EU, with manufacturing facilities in the UK, France, Germany and Spain. The UK is mainly responsible for making the wings and landing gear for Airbus's commercial airliner. Over 1,000 wings are produced in the UK each year. They are then flown on a specialised plane called the Beluga to assembly lines in France and Germany. Airbus have stated that they have several of these movements every day, and it's vital that each delivery has a turnaround of only 2 hours, a time constraint that we will later show Brexit to disrupt. It would seem logical for Airbus to move wing and landing gear manufacturing to continental Europe to be closer to the assembly plants, thus reducing transportation costs. However, Airbus avoids doing so only to take advantage of the human capital and infrastructure that is already present in the UK. While Airbus would therefore ideally want to minimise the amount of manufacturing they conduct in the UK on the other hand aims to maximise it to reap the benefits of increased national output and reduced unemployment. Not to mention the less empirically observable advantage of technological spillovers into other domestic industries such as the automotive industry. Essentially, we have two players with opposing incentives bargaining for the share of the same pie. This makes an ultimatum game the ideal way of presenting the situation, whereby Airbus, the proposer, offers some amount of work to be outsourced to the UK. Knowing that the UK has specialist facilities for landing gear and wings already, Airbus offers the two components to the UK to produce. The UK has only two options: accept or reject the offer. If the UK accepts, the UK will produce wings and landing gear represented by the payoff W plus LG, and Airbus will produce everything else in continental Europe, hence the payoff E minus W plus LG. On the other hand, if the UK rejects, then the UK will not reap any of the benefits previously described, giving a payoff of zero. Equally, Airbus will need to relocate facilities elsewhere, a costly disruption to the entire process if unplanned that will incur delays, giving the same payoff of zero. The game is solved by finding the Nash equilibrium, the point at which there is no action that any player could deviate to that yields a higher payoff given the actions of all other players. The Nash equilibrium in this game is as follows. Under the assumption of monotonicity, the UK will always accept any offer greater than zero, as it strictly prefers exporting something to exporting nothing. Knowing this, Airbus offers the minimum possible amount of manufacturing work to the UK, and the UK subsequently accepts the offer. However, as we can see, this is not entirely what we observe. Airbus currently offers more than the minimum and could technically further reduce their offer to just wings or just landing gear. The problem Brexit poses is that of non-tariff barriers to trade, namely regulatory divergence leading to customs procedures and additional administrative requirements causing delays at the UK-EU border. In the case of Airbus, this would delay, for example, the rate at which the Beluga aircraft could do its transportation trips. Tariffs after Brexit are not expected to be an issue. This is because of the World Trade Organization's agreement on trade in civil aircraft, to which both the UK and the EU are parties in their own right. The agreement eradicates tariffs on aircraft and most aircraft components. So Brexit therefore poses the problem of costly delays in the manufacturing process, and the cost would quickly increase when considering the opportunity costs of such a lengthy project. The delays are said to incur an estimated cost of £1.5 billion per year. Because of the cost of delays, we would expect to see a shift in Airbus's decision to offer even less outsourced work to the UK to avoid the costs. Airbus may now offer only landing gear or only wings to be made in the UK with the aim of relocating production of one component elsewhere. Brexit therefore causes a further shift towards the game-theoretic prediction of Nash equilibrium. If delays are lengthy and therefore costly enough, Airbus's strategy may involve retracting all UK operations, which would be costly in the short run, but would pay off in the long run if delays at the border persist. The main lesson that we've learned is that Airbus's strategy will conform to the prediction of Nash equilibrium as a result of Brexit. This is important information for competitors such as Boeing to anticipate, as they may wish to exploit the gap in the UK's aerospace industry if they are better able to overcome the associated costs. Another lesson learned is Nash equilibrium is not always observed in reality. This is perhaps due to the other variables not considered in the setup of the model. For example, people might make mistakes, or they might not be rational. And finally, the outcome is heavily reliant on the assumptions made. We made the assumptions of monotonicity and payoff maximising players, which affected the outcome. If we assumed a different utility function, for example one that depends on the utility of other players, the outcome may be different. Thank you for watching.